So we've talked about the linear function, y equals mx plus b, or f of x equals mx plus b, where if we knew the slope and the y-intercept, we could write the equation of a linear function. We're now going to talk about exponential functions, or exponential growth specifically. Y is the amount of substance or population at time x. C is the initial amount, or the y-intercept, kind of like our b was in our slope, point slope or slope-intercept form. The c is our initial amount in this formula. A is called a growth factor if a is greater than 1. It's a decay factor if a is less than 1, and we'll talk about that a little later. But for right now, if it's growing, our a has to be bigger than 1, and it's the amount by which y is multiplied when x increases by 1 unit. So for example here, the initial population is 4,500. The population triples every time period. So our equation is going to be y equals, it's got to be an equation, so we need the y equals here. Initial quantity, 4,500 times, and then it triples, so that is our growth factor every time period, and that's our x input. So if x is 1, we multiply 3 times 4,500 and we've tripled our amount. If I put in 2, then it's going to be 3 times 3 times the 4,500, and we've tripled it again. The initial amount is 34,000 and it has a growth factor of 1.15. So again, we go right to the equation. Y equals 34,000, and our growth factor is 1.15x. All right, so again, if we plug in 1, we can see how it increases over time. It's going to be a number bigger than 34,000 because we're multiplying it by a number bigger than 1. So for this one, the initial population is 74 million. Now, because they use the word million, I'm not going to tack on all the zeros. I'm just going to remember that when I put my answer in, if I'm plugging into it, I'm going to have to remember that my answer is in millions. So we're going to start out the same way. Y equals 74. And now I'm looking for a growth factor. The percent is a rate, a growth rate, because it's increasing. But 2.5%, we need to convert to a decimal. You can't use a percent in an equation here. So to convert the 2.5% to a decimal, you move the decimal over 2 places to the left, or divide by 100, and you get 0.025. But the thing is, if I put in 0.025, that number's not bigger than 1. That's just telling me the little bit of a portion that I'm increasing by, but it doesn't take into account my original amount. So to do that, we add 1 to that number, and that gives me the growth factor. Think about it this way. The 2.5% is almost like a tip in a restaurant, but you still have to pay the bill, and the bill was the original amount. That's my original amount is the 1, and then the extra is my tip. So 1.025 then is my growth factor, or the total amount that it's growing by. So in example 36, all right, we have the U.S. during the first decade of the 2000s, live births to unmarried mothers, represented by B of t, grew according to the exponential model. T is the number of years after 2000. So, for example, if I'm talking about the year 2000, t would equal 0. If I'm talking about the year 2001, then t would be the number 1. It's the number of years after 2000 that I'm plugging in for t here. For this one, what does the model give as the number of live births to unmarried mothers in the year 2000? That's my initial amount. because that's where we're starting with at 2000. So my initial amount is this number in front here, 1.3 times 10 to the 6 live births. Another way to compute that is the initial amount is when t equals 0, and I could plug in t is 0. So births at time t equals 0 is, and then I could use my calculator to compute this out as well. Raised to the 0 power, because that's the year 2000. You don't plug in the year 2000 though. All right, and you'll come back to this number here, 1.3 times 10 to the 6. Make sure you put a unit label after your number so that we know what you're talking about. For part B, what is the growth factor? That's what you're multiplying your initial amount by. So my growth factor is 1.033. Right. What does the model predict for the number of live births to unmarried mothers in the year 2010? All right, so in 2010, I'm going back to my formula, but the t isn't 2010. Remember, we're not plugging in the whole entire year. It's the number of years after 2000. So I've got to subtract 2000 from that, and that's 10 years beyond the year 2000. So t is 10 that I'm plugging in. So I got 1.3 times 10 to the 6, and then multiply that by 1.033 raised to the 10th power. Here's where you want to get your calculator out. Make sure you can type it in and come up with a number. The number that I came up with was this, and they want me to round to the nearest whole number. So I came up with this number, 1798649.6, and there were a bunch of other digits after that. But to the nearest whole number, that 6 is bigger than 5, so that's going to bump the 9 up to a 0. So that's going to make that those last two digits the number 50. So 17,98650, and then the unit label on it is live births. If you don't put the unit label on it, there's going to be a point or two taken off, so make sure you're putting that unit label on there for the word problem part. Okay?